Okay, here's another, just to find the derivative, but we're going to have to use our chain rule. Now remember, the derivative of e to the x is just e to the x. In this case, it's going to be e to the u, so the derivative of this will be e to the sine 2x times the derivative with respect to x of the sine of 2x. So y prime will equal e to the sine 2x, and what's the derivative of the sine of 2x? That's just going to be cosine of 2x times the derivative of what's inside that cosine, which is 2x. So that's going to end up equaling e to the sine 2x cosine of 2x, and what's the derivative of 2x? Just 2. So another double chain rule application. And we could probably put the 2 and the cosine in front. Well, I could actually just put the 2 in front, so we end up with y prime equals 2 e to the sine 2x cosine of 2x. Okay. And then number 14. Okay. Y equals log. So we have log to the base a. This is the log to the base 3 of x squared. So we do have a chain rule. U equals x squared. Du dx equals 2x. And this is our good old log formula. And that one there, remember, log to the base a of x is 1 over the natural log of a times x. So my base is 3, so y prime will equal 1 over the natural log of 3, times my u in this case, so my u is going to be x squared, times the du dx, which is times the 2x. Put that up on top if you want. So y prime will equal, and then one of these x's will cancel, so I just have 2 on the top, left, and I have x natural log of 3. We could write it like that, x natural log of 3. So that's all you have there for 14. Okay, number 15, I'll just save a little bit of time, so we'll just kind of take a look at the solutions on these, and I'll just go through how we come up with them. And this is like we did on our mid-chapter test. I hope you can see those intervals. Okay. Bleeding through. Maybe this won't, sometimes it won't bleed through if I... Yeah, this actually will look better just without the white underneath it. So let's try this here. There we go. I think you can see those better now. A little bit anyway. Okay, so you're going to have to look at your test because these letters are kind of small. Okay, so this is our good old velocity graph. We've done these before. The accompanying figure shows the velocity of a particle moving on a coordinate line. Answer the following questions. Okay, when does this particle move forward? Okay, this is the velocity, so it moves forward whenever the velocity is positive. So it moves forward here whenever it's above the line. That's all. So you can just do it like that, and whenever it's above the line. So it looks like it's above the line from 0 to 1 and from 4 to 6. Okay, so that's when it's moving forward. When it's moving backwards, whenever it's below the line, so I can cover this up, and whenever it's below the line, it looks like that's from 1 to 4 and from 6 to 7. And we're only going from, actually we're just talking, and I should have specified this over here, but we're just moving from 0 to 7. That's all we have on our graph. So we would close that off at 7. Okay, when does a particle speed up? Well, remember, it speeds up. There's a couple ways to look at this. It speeds up when the velocity and the acceleration have the same sign. Okay, when we're looking at a graph, it's a little bit easier. We can just say when it's moving away from 0. So it looks like it's speeding up from here to here, from 1 to 2, because it's moving away from 0. Also, the slope is negative and the velocity is negative, so the slope of the velocity, so that's acceleration is negative, and the velocity is negative. All right? And it's moving away from 0 between 4 and 5. Okay? Again, the velocity is positive and the acceleration is positive. That's the slope. And that's the moving away from 0 from 6 to 7. Okay, so that's when it is speeding up. And here the velocity is negative because it's below the graph, and the acceleration is negative because the slope is going down. Okay. All right, letter D. When does it slow down? Well, it slows down when it's moving towards zero, or when the velocity and the acceleration have opposite signs. Here the velocity is positive, but the acceleration is going downhill, it's negative, so that means it's slowing down from 0 to 1. Okay. Also from 3 to 4, you can see that the velocity is negative, it's below the graph, but the acceleration is positive, it's going uphill, 3 to 4, or it's going towards 0, and also from 5 to 6. 5 to 6, it's going towards 0, or you can think of the fact is that the acceleration is positive above the graph, but the velocity is positive above the graph, but the acceleration is negative going downhill. That's the slope of the velocity. All right, so that'd be 5 to 6. So again, it's slowing down 0 to 1, 3 to 4, 5 to 6. All right. So it's good to remember, and this will work on the AP exam. Sometimes they'll ask you to justify or ask you, is the particle speeding up or slowing down, and why? Justify your answer. So you'd say it's speeding up because the velocity and acceleration both have the same sign. And you don't have a graph. You don't have to use a graph to do that. Okay. When is the acceleration positive? The acceleration is positive whenever the slope is positive of the velocity, or whenever it's going uphill. And it actually happens to be positive here, and it's still positive. It didn't even zero out here, so it's still positive from 3 to 5. And that's about it. So if you look at from 3 to 5, it's going uphill. Okay. When is it negative? When is it going downhill? Well, it's going downhill like this, so that would be from 0 to 2. And it's also going downhill from 5 to 7. That should be a closed bracket there, 5 to 7. Okay. And when is the acceleration 0? The acceleration is 0 when the slope of the velocity is 0, and that's right here. So that's 0. So that would be just between 2 and 3. And when does the particle move at its greatest speed? Well, its greatest speed it's the absolute value of the velocity. So it doesn't matter whether the velocity is positive, negative, that's left or right, just the farthest away it is from the 0. And obviously it's down here, so that's at 7. So t equals 7, that's the most. Okay? All righty, hope that helps you out there.